Good morning, gentlemen. This is an example of a question. This is actually from the quiz from last week, question 11 from the quiz. And I wanted to do an example slowly on video so that in case in following along with the explanations in class, if you're feeling like, well, I'd like to be able to back that up, listen to it more closely, more slowly, that you have an example where you can do this. And the thing about this example that we have here is that it's got a lot of different principles going on that can sometimes be tricky, right? I've got exponents outside the brackets. I got negative exponents going on. I got coefficients inside the brackets, which can often throw people off. So let's look at this example here and see how we do it. So if you look at the start here, you got this 2 outside the brackets and this minus 3 outside the brackets. Let's deal with getting those inside to each of the elements inside the bracket. So I've got, let's see on the top here, I've got this 6 to the minus 2, right? The distributing the exponents to each of these, usually people are fine when they're dealing with letters, but for some reason with the coefficients, especially if the coefficient like this guy here doesn't explicitly have an exponent showing, like this is actually 6 to the 1, then it's easy to lose track of the fact that this exponent has to hit that coefficient as well. So on the top here we have 6 to the minus 2. We're going to multiply this exponent of 2 times this exponent over here, and this new guy is going to become 6 to the minus 4. All right, we'll deal with the negative in a second, but for now, let's just deal with this outside exponent. The a cubed becomes an a to the 6th, again, because I multiply the exponents together when I have a power outside the brackets like that, and b to the minus 8. So far, again, all I'm doing at this stage is distributing the exponent to each of the elements inside the brackets. Here I've got 6 to the 1. I've written a little 1 in there, again, to remind me that this exponent has to combine with that exponent. This becomes 6 to the minus 3. And then a cubed, 3 times minus 3, that gives me a to the minus 9. And finally, b, again, if I need help, I can put a little 1 there. This is b to the 1. 1 times minus 3 gives me b to the minus 3. Okay, so now I've simplified things in that I no longer have these exponents outside the brackets. But now at this point, there's various things you can do. Some people say, and we're going to do it both ways, some people say, well, you know, I'm used to the division rules that we saw last year in secondary 2 algebra, where if, like, this is a fraction, right, that means the top divided by the bottom. I know that I have to subtract exponents when I'm dividing. So let's do it that way first, okay? We'll do it another way in a second. You can say to yourself, okay, so I got to divide each of these by subtracting the exponents. 6 to the minus 4, I do minus 4 minus minus 3. All right, minus 4 minus minus 3. And minus 4 minus minus 3, that's like minus 4 plus 3. If it's minus 4 degrees outside, it gets 3 degrees warmer. That's going to be minus 1. So I have 6 to the minus 1. Notice that the base stays the same. It's only the exponent that changes. Likewise, I say, okay, 6 minus minus 9. That's like 6 plus 9. That's 15. So I have a to the 15 here. And then I have b to the minus 8 and b minus 3. So minus 8 minus minus 3, that's minus 8 plus 3. That's like minus 8 degrees outside. It gets 3 degrees warmer. It's going to be b to the minus 5. Okay. And so now at this point, I've essentially got my answer, and I know that I need to express it with positive exponents. So let me just find a way to get all these negative exponents positive. And the way you do that is you just take them across your fraction line, right? This is all over 1. So if I move this negative guy down here, right, he's going to become a 6 to the positive 1, right? So I've taken care of him. Let me scratch him out. a to the 15 stays where he is, up here. And then b to the minus 5, I got to turn that negative exponent to a positive 1. I do that by moving this guy down below the fraction line, okay? Now, I don't actually write this exponent of 1. My final answer would just look like this, a to the 15 over 6b to the 5th. But that's my answer, okay? Now, if that made sense to you, great. Stick with that. I'm going to show it to you another way. Once we got the exponent distributed to each of these brackets here, we could say, okay, let's say I actually, the negatives are the thing that throw me off the most when I'm dealing with exponents. So I want to get rid of them as quickly as possible. This is another correct way of doing the same problem. You can say, all right, first priority, I'm going to look around for every negative exponent. Whenever I see a negative exponent, I'm going to move it to the other side of the fraction line. Now, in this specific example, you've got 5 negative exponents to deal with, so this is a lot of work. In some examples, you might have only 1 negative exponent, right? So in this case, it's going to be a lot. In other cases, it might be not very much. So here I've got the 6 to the minus 4. Let me start with him. Okay, I got my fraction line here. 6 to the minus 4, if I put him on the bottom, that becomes a positive 4. I've got him taken care of. I'm going to scratch him out. I've got a to the 6th. He's going to stay up here, right, because he's already got a positive exponent, so I leave him there. B to the minus 8, negative exponent. Let me have him switch sides over to the other side, and now this becomes a b to the positive 8 because I've switched the sign of the exponent. All right, 6 to the minus 3. I want to make that positive, so I'm going to put 6 to the power of 3 up here. This looks kind of like a b because my b's look like 6's, but this is meant to be a 6. Okay. A to the minus 9, I want him to be positive, so I move him from the bottom up to the top, and I make him into an a to the 9th. B to the minus 3, I want him to be positive as well, so I'm going to move him up to the top, b to the positive 3. So it's not that by moving a negative exponent to the top it always becomes positive. It's just whenever you switch sides, whenever you move an exponent across the fraction line, one way or the other, right, it goes from positive to negative, negative to positive, depending on, like if it starts out as negative, you move it across this line, it's going to become positive, right? If for whatever reason I wanted to move a to the 6 down to the bottom, it would become a to the minus 6. But just moving across the fraction line changes the sign of the exponent. Okay, so now at this point, I've got no more negative exponents. If I hate negative exponents, then this is great for me. Now I still got to simplify, but I'm in good shape. So if I simplify the top, I got a 6 to the power of 3 here. So that's still 6 to the power of 3. I've got a to the 6th and a to the 9th. In multiplying those together, I don't multiply the exponents together. I'm going to add them together. That gives me a to the 15th. And then I've got my b cubed, right? So all of these guys have simplified together on the top. On the bottom, it's already pretty much as simple as it can be. I got 6 to the 4th, b to the 8th. So now at this point I could say, all right, I've simplified a little bit, but there's still some canceling that can happen, right? I've got 3 b's up here. This is b times b times b, and this is 8 b's down here, b times 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 b. So let me knock out 3 of the b's up here and 3 of the b's down here, which will leave me with just b to the 5th, right? These 3 b's cancel out 3 of the 8 b's down here. I'm left with b to the 5th. I've got 6 3's up here. They're going to knock out 3 of the 6's down here, and I only have 1 6 left, right? 4 minus 3 gives me 1, so I've got a 6 still left down here. And the a to the 15, there's no a's down here to cancel with, so I'm left with a to the 15th up here. So in both cases, I end up with a to the 15th times a to the 15th over 6b to the 5th, and I should be getting the same answer both ways. If both ways are correct, that means you should get the same answer both ways. In this case, I do. So that's 2 different ways you can handle dealing with one of these complicated questions with outside exponents, negative exponents, canceling to do. Whichever way you find easiest to comprehend is the way that you should adopt as your method of going with, because both of them are perfectly good, perfectly acceptable, perfectly sound.